Hello, welcome to Operations Management. In this lecture, I will talk about forecasting errors. Firstly, an error, sometimes they will be calling it as a deviation, is the difference between the actual value minus the forecasted value. So, for any time period t, you are trying to see what did you forecast and what was the actual value, and if you take the difference, it's an error. Suppose we forecasted 10 for a certain day of a week and the actual value turned out to be 8. So the forecasting error would be -2. So that is how we will be doing. That's how you will calculate error. So in this we have different forecasting methods, error methods. So one is MAD, which is mean absolute deviation. So the formula for this MAD is, as you know, deviation is error and absolute means if for example here we have -2, the absolute value of -2 would be +2. So you are only considering positive values. So any negative value you will convert it into a positive value, and mean is you will take the average of all the errors you make. So the formula is summation of a of t minus f of t divided by n. So here I will try to write this is actual and this is forecast for a time period t. So if you see a of t minus f of t, for each time period you are calculating the error here in this, and then you are taking the average, which is sum of all the numbers divided by n. So that is the MAD. And the next method would be MSE, which is mean square error, mean squared error. So as the name specifies, we have an error, we square it and we take the mean of it. So the formula for MSE would be summation of a of t minus f of t. Now this is the error part, so I have to square it, divided by, now I have to take the mean of it. So this should be divided by n, because if you have done statistics course, you lose 1 degree of freedom if it is a sample. So we will write n minus 1. So this is again an average term or a mean term. And then finally we have MAPE, which is mean absolute, this is absolute percentage error. So again the name specifies you have error, you take the percentage of that error, and then you have an absolute error, and then you take a mean of that. So the formula for this would be MAP is summation of absolute error, which is a of t minus f of t, divided by the percentage, means you are comparing it with the actual value, and then you multiply with 100 to get the percentage, divided by n. So again you are taking the mean of the percentage errors. So this looks, the formula looks complicated, but it's very easy to solve. We will try to solve a problem on this. Maybe I will move to a next page. So we have XYZ company and it sells chairs. So on a certain day, which is Monday, the actual value, this is actual, and then this is forecasted. So that means actual value for each time period is represented by A of t and forecast is represented by F of t. So this is Monday, Tuesday, Wednesday, Thursday, and then I have Friday, so these will be given, these you will be having these when you solve problems on errors. So or forecast you might be predicting by using certain technique, but actual values will be given. So this is 20, 30, 15, 35, 20, and then the forecasted values are 10, 20, 30, 15, 35. So the first technique I will use is MAD. So I will use first technique is MAD. In MAD, the first thing is the deviation and the absolute deviation you have to calculate. So I will write absolute deviation here. So which is AD. So absolute deviation means now I am doing here this is 20. 20 is the actual value and the forecasted value is 10. So the difference would be you forecasted 10 but the actual value turned out to be 20. So the error will be 10 units. Here you forecasted 20 and then the actual value turned out to be 30. So the error would be 30 minus 20. So I will do minus here. That would be again 10. Here the error is you forecasted 30 units and the actual value turned out to be 15. So the error is, now this is an absolute error, that means you are always considering positive values. 15 minus 30 is negative 15, but the error you made is 15 units. Again 35 minus 15, the error is 20. And finally 20 minus 15, the error is 15. So that's how you will calculate. So the next thing is you will do the MAD. You will take the average of all these absolute errors. So you are taking the average of all these numbers. So that would be 10 plus 10 plus 15 plus 20 plus 15 divided by 5, that is going to give us 14. So the mean absolute deviation would be 14. And then I can use similarly MSE. Now if I wanted to do MSE, I need a squared error. So first I am squaring the error. So I am using this part, squared error. So that is SE I am calculating. So again here I am squaring the error. My error is, if you see, 20 minus 10 is 10. Now I have to square it, that is 10 square is 100. Then the next one is 30 minus 20. I have an error of 10 and I square it, so that's again 100. Here 15 minus 30 is 15, so I do square of it, that's 225. 35 minus 15, I have an error of 20, so I square it, that's 400. And then 20 minus 35 is 15, I square that, so that is 225. So the formula for, so I have squared error, now I have to take the mean of it, MSE. The formula is summation of, summation of, maybe this is summation of, this is not right, a of t minus f of t whole square divided by n minus 1. So that means I need to, the top term would be, I need to add all of them, that is 100 plus, I will add this, plus 100 plus, I will add this 225 plus, I will add this 400 plus 225 divided by n is 5. So 1, 2, 3, 4, 5, 5 minus 1. So this is going to give me MSE is 1050 divided by 4, which is 262.4. So that's the MSE I'm going to get. Now the final one is mean absolute percentage error. I will write here mean absolute percentage error. So you are taking absolute percentage error. So that is absolute error. So I will write absolute as ABS error divided by actual value, which is multiplied by 100. So I'm at this time I'm only doing APA. I will take the average later on. So absolute error is I have those values here, 10, that's my absolute error, divided by actual value is 20 multiplied by 100. So that is going to be around 50% error I made in this. Right, so absolute error is how much error you made during, how much percentage error you made during each time period forecast. So here I forecasted 20 and the actual value turned out to be 30. So absolute error is 10 divided by the actual value is 30 multiplied by 100. So this is going to give me 33.33%. So third one, I made an error of 15 and the actual value turned out to be 15 multiplied by 100. So I made a 100% error. Again here I have my absolute value is 20 and the absolute error is 20 and the actual value is 35 multiplied by 100. So the error I made is 57.14. Finally here I made an error of 15 and the actual value turned out to be 20 multiplied by 100. So I made a 75% error. So to calculate MAPE, I have to take the average of those numbers, MAPE. So I have to take the average of 50%, 33.3, 100, 57 and 75. So that is 50 plus 33.33 plus 100 plus 57.14 plus 75 divided by 5. So that is going to give me 63.06%. 0.095%. So on an average, I'm making an error of 63.095 error. So if you are comparing two models, the thing is you have to compare over long run which one has the least error. So suppose I'm comparing knife with exponential smoothing. I will calculate I will use one of these techniques like MAD. Suppose I use MAD for knife and I get an value of suppose I will use the same thing 14, and exponential smoothing I will write ES. I get an MAD of suppose 22. So this is, I am assuming, okay, these values at this time for convenience. I have to go through the process, all these calculations to get this. So in this, if a manager wants to determine which model is best, the naive model is best because the error we are making is less on an average compared to exponential smoothing. So this is the best model. So this concludes my lecture on forecasting errors. Thank you.